So here we are in the plane, and I discovered there's not enough slack in this cable to hook this up the way I'd like and also get it in the shot. So to keep it visible to you guys, it's going to be backwards to me. So the cable just plugs in right like that. And I've got these instructions that I'll periodically turn to read. I've already pulled the breaker. So item 1 is to switch in the 10K resistor for socket 2, which is this switch here, switches it in, and verify the voltage on socket 2 relative to socket 8, which is ground. So I just plug in the ground probe here, tighten it down, it's got a good grip there, and then socket 2 is right over here. What am I looking for? 0.4 volts max. And you can see I've got 0 volts, so that satisfies, it says actually 0 to 0.4 volts, and that's what we have. So now the next one is socket 3, and that should be 24 volts. So we switch in the resistor for socket 3. Clamp down on the probe for socket 3, and you can see we've got 24.79 volts. So now we remove the 10K ohm resistor. That's the middle position on this switch. And do the diode check with the negative lead in socket 3 and the positive lead in socket 1. So here's the diode check. Negative lead goes in socket 3. Positive lead goes in. This isn't really backwards to you guys, it's backwards to all of us. Me too. And it says that the voltage should be 0.5 plus or minus 0.3, and that's what we've got. Next test is negative lead in socket 3, positive lead in socket 2, and it should be 0.5 plus or minus 0.3. So positive lead in socket 2 goes over here. And that's 0.5 plus or minus 0.3. Oops. And now we want the negative lead in socket 1, positive lead in socket 3. And that should give us an open condition. Which is what we have. And then negative lead in socket 2, positive in socket 3. This is much easier if I'm not turning it around to try and keep it oriented to the camera. It wouldn't be falling apart like this as much. And that also gives us an open lead, an open circuit. So now we have to close the circuit breaker and do some more tests. So I'll be right back after closing. Okay, so the circuit breaker is closed, and now tests we're making are voltage checks. They're all relative to socket 8. So we can put the negative probe into the socket 8 terminal here, clamp it down. And the first one is socket 1 should be 24 volts. So we've got 25.37. Don't know how serious that discrepancy is. Second one is socket 2, which is measuring battery 2 and should also be 24 volts. So there we go. Again, a little high, but batteries are expected to be higher than their nominal voltage actually. Socket 3, the igniter switch diagnostic, is also supposed to be 24 volts, and it's the same thing. Socket 4 and socket 5 aren't used, so I don't have test points for them. Socket 6 is supposed to be 0 volts. And that's what we've got. Socket 7 isn't used, and the shield ground is supposed to be 0 volts. And that's what we have. So the last test here, there are two resistance tests. So the resistance between socket 8 and socket 6 is supposed to be 100 k ohms plus or minus 10. Plus or minus 10 k ohms, I guess. So 8 and 6. Switch this to ohms. And we've got 98 k ohms. So that passes. Did you see it there? I don't know, why is it giving me a flashing? There it is. I'm calling that 98 k ohms. And then the last one is the cable shield, which is supposed to be less than 1 ohm. And when I was testing that earlier, I was getting an open circuit. But now, okay, so now it's a low resistance, 6.7 ohms, and I'm going to call that less than 1 ohm because these meters don't really read that well at such low resistances. I'd need a special meter or adapter to really accurately go below 20 ohms or so. So I think this passes everything. Hope that helps.